question 21. Question 21 is testing you on the topic of a redox, which is reduction and oxidation. And to be more specific, it is actually looking at whether you are able to determine the oxidation states of the elements in the compound here. All right, so given the following reaction, what can be deduced from the equation? What I can recognize from this equation is this ion, MnO4 minus ion, and MnO4 minus ion. This is one of the oxidizing agents that you guys will have to remember. Okay, so what I can eliminate from the options is actually option B, MnO4 minus. It is acting as the reducing agent. This is not true because MnO4 minus is an oxidizing agent. All right, so the next thing I would do is to actually determine the oxidation state of the different elements, especially sulfur. Okay, the sulfur atom. So let's take a look at the oxidation state of sulfur atom in this ion sulfite, Fite ion. Okay, so oxygen atom, or basically in this case, the oxygen atom in the sulfite ion, it generally has an oxidation state of a -2. And because I have 3 oxygen atoms here, the negative charge in total, I will have -6. Okay. The overall charge of this polyatomic ion, based on the charge of the ion here, 2 minus, it is equals to -2. So the charge or the oxidation state of the sulfur atom, of this one sulfur atom, I let it be X. Therefore, X is equals to -2 plus 6, which is +4. The oxidation state of sulfur in this sulfite ion, it is +4. Now, let's take a look when we do the same method to calculate the oxidation state of sulfur in sulfite. Okay, I don't want to use red. Let's change to blue. Okay, sulfite, sorry. So I have 4 oxygen atoms, with each of them carrying an oxidation state of -2. So the total negative charge I have is -8. Okay, and the overall charge of this ion, it is -2. Hence, the oxidation state of my sulfur atom, it will be A equals to -2 plus 8, which is equals to +6. Okay, so +4 to +6, you realize that the oxidation state increase. Oxidation state increase means that it is being oxidized. Okay, it is oxidized. Sulfite is oxidized to form sulfate. Hence, the answer is C. However, let's take a look at the other options. What about D? Sulfite, Fite, it is neither oxidized nor reduced. This is wrong because there is a change in oxidation state of sulfur, which we have calculated. Hence, sulfite has been oxidized. Okay, so let's take a look at option A. H plus is oxidized. Okay, so the oxidation state of H plus here, let me change color to green. Oxidation state of H plus here is +1. When you look at the oxidation state of hydrogen in water, okay, -2, the overall charge is 0 because this is a compound. I have 2 hydrogen atoms, so let's say 2x. Therefore, 2x is equals to 2x is equals to +1. All right, the oxidation state of hydrogen in water is also +1. Because there is no change in its oxidation state, H plus is it is not oxidized nor reduced. Okay, it is neither oxidized nor reduced. Hence, A is out. Okay, the answer for this question is C. Okay.